In section 4.3, we're going to be looking at rectangles. So the lesson objective, I know and can use properties of rectangles to find unknown lengths, variables, and angle measures. So note a rectangle is a parallelogram with 4 right angles. And note that these are 90 degrees. And so since a rectangle is a parallelogram, then a rectangle also has the following properties. So opposite sides are parallel and congruent. And those come from being a parallelogram, as well as opposite angles are congruent. And consecutive angles are going to be supplementary, but also note here that since our angles are 90 degrees, they are also going to be congruent. And then diagonals bisect each other. And those all come from being a parallelogram. In addition, so not only is it a parallelogram, but in a rectangle, the diagonals are congruent. So that's saying that this side is congruent to this side. Not just that they bisect each other, but that the diagonals are also congruent. So an example, a rectangular park has 2 walking paths as shown. So if PS is 180 meters and PR is 200 meters, you can see we have a triangle here. We want to find the length of QT. So that would be this distance right here. So since the diagonals are congruent, we know that this distance as well is going to be 200 meters, but then they bisect each other. So then we are going to get that QT is 100 meters. So just note again, since one diagonal is 200, the other is 200 since they are congruent, and then they bisect each other, so it is half of that, so it's 100. So now if TS is 120 meters, so TS here is 120 meters, we want to find the length of PR. So since they're congruent and they bisect each other, we know that this is also 120. Multiplying that by 2, since they're congruent, we get that it is 240 meters. Example number 2, quadrilateral JKLM is a rectangle. If the measure of angle KJL, this angle right here, is 2x plus 4, and the measure of angle JLK, so JLK is 7x plus 5, then we want to find the measure of x. JLK is 7x plus 5. We know that together, here we have a triangle, but also note that we have 2 parallel sets of parallel lines here with a transversal, and so we have consecutive interior angles. Oh, hang on. Let's rewind. We have this measure is 2x plus 4, and this measure is 7x plus 5. Since we have parallel lines, we know that alternate interior angles are congruent, so that would be this angle and this angle. So we also know that this angle is 2x plus 4. But together, we know that this is a right angle since it's a rectangle. So we can take 7x plus 5 plus 2x plus 4 set that equal to 90. We'll get 9x plus 9 equals 90. So then we get 9x equals 81. So we get x to be 9. Sorry, rewind to the start of that one again if you need help. So then note that opposite sides must be congruent and diagonals must be congruent. And so we're going to look again at solving for the slopes and the distances. So looking first the distance between different points. So the distance between P and Q. Remember our distance formula is the square root of x1 minus x2 squared plus y1 minus y2 squared. So using this formula, we're going to get the square root of 52, square root of 52, and then the square root of 13, square root of 13. So we can see that opposite sides are congruent. Using the same formula for our diagonals, we get the square root of 65, square root of 65. And so then you can see that our diagonals as well are congruent. So therefore, yes, this is a rectangle. So using the Pythagorean theorem, quadrilateral WXYZ is a rectangle. So if XW is 3, YZ is 4, WZ is 4, we want to find the length of YZ, or of WY. So we're looking first for XZ. So using our Pythagorean theorem, we can take 3 squared plus 4 squared equals 9 plus 16. So that gives us 25. So then xz, since that is c, we get the square root of 25 is 5. And then note that since it is a rectangle, the diagonals are congruent, so wy is also 5. So that completes 4.3. In this same video, we are going to move on to 4.4, and we're going to be talking about rhombi and squares. So the lesson objective is I know and can use properties of rhombi and squares to find unknown lengths, variables, and angle measures. So rhombus is a parallelogram with 4 congruent sides. And then since a rhombus is a parallelogram, then the rhombus also has the following properties. So note again, the opposite sides are parallel and congruent. Opposite angles are congruent. And consecutive angles are supplementary. And then diagonals bisect each other. So again, that's just reiterating the properties of a parallelogram. So in addition to those, in a rhombus, the diagonals are perpendicular. And then also in a rhombus, each diagonal bisects the opposite angle. So that's like saying that angle 1 is congruent to angle 2, angle 5 is congruent to angle 6, and so on. You can give me multiple examples here. So practice problem 1, given quadrilateral ABCD is a rhombus, find the following. So we know that ABCD is a rhombus, and then the measure of angle BCD is 64. We want to find the measure of angle BAC. So since it's parallelogram, we know that these are congruent. And we also said just above that in a rhombus, each diagonal bisects each other. So taking half of 64, we will get the measure of angle BAC to be 32 degrees. Next, if side AB is equal to 2x plus 3, and side BC is equal to x plus 7, we want to find side CD. And note that in a rhombus, all sides are congruent. So we first need to solve for x. So we can set 2x plus 3 equal to x plus 7. And we get x to be 4. Plugging that back in to one of our sides, let's plug it back into x plus 7. We can get 4 plus 7 equals 11. So sides are equal to 11. So side CD equals 11. The last quadrilateral we're going to look at is a square, or the last parallelogram, I should say. So a square is a parallelogram with 4 congruent sides and 4 right angles. So note this is kind of like a rhombus and a rectangle together. You guys have seen squares before. I'm sure this is not new news to you. So just to organize this, parallelograms, right angles are rectangles. Congruent sides, we have rhombuses or rhombi. And then both congruent sides and right angles, we have squares. So all of these are parallelograms, but a square is both a rectangle and a rhombus. So note the difference between all 4 of those. Example number 2, the diagonals of a rhombus W, X, Y, Z intersect at V. Use the given information to find each measure or value. So if the measure of angle WZX, we have WZX is 39.5, we want to find the measure of angle ZYX. So ZYX. So we're looking for this part right here. First, we need to note that this angle right here is 2 times 39.5. So this angle is 79 degrees. And then remember that consecutive angles are supplementary. So we're going to take 180 minus 79 to give us the measure of angle ZYX to be 101 degrees. Part B tells us that if WX is 8x minus 5 and WZ is 6x plus 3, we want to find x. Note again, in a rhombus, all sides are congruent, so we can take 8x minus 5 and set it equal to 6x plus 3. We get 2x equals 8, so we get x to be 4. Our last example here, we have WXYZ is a square. If WT equals 3, we need to find each measure. So WY, then remember that the diagonals are going to be congruent. So this is going to be 2 times 3, or 6. TZ, if the diagonals are congruent and bisect each other, then TZ is going to be 3. The measure of angle WTZ, so WTZ is going to be a right angle since it's a rhombus, so it's going to be 90 degrees. And then the measure of angle WYX, so WYX right here. Remember, since it's a rhombus, that the diagonals bisect the angles. And since that angle is 90 degrees, we can divide it by 2, and we get that degree to be 45. Thank you for listening. Hopefully you know the difference between parallelograms, rectangles, squares, and rhombi now.